Hey guys, today I'm gonna do a video about treadmilling. Not sure if I did one before, but this is your treadmilling tool. This is a M6 by 1 pitch, and the reason I use most of the time I do tap, but the reason I use a treadmill is because of sometimes some materials they don't like to be tapped pretty much, and what happened with my broken tap yesterday, I was able to use an end mill. So I set an end mill as a drill. I was able to put out the broken tap and pretty much just treadmilling. The treadmill, pretty much, so let me explain how it's set. So treadmilling, there's an option which is called planet tapping, I think, or is a planet milling, and for that option you have to have like almost a full form treadmill. It just goes in, it does like 1, 2, and then it comes up. With this type of treadmill, you can pretty much go all the way, or almost to the shank. So pretty much if you have a part like this, they will just kind of spiral, go in, and then it's gonna come out. So now the important thing is, so obviously to do treadmilling or do circle mill, the machine will do it only with an end mill. So we had to light, okay, and I called it, I set it at end mill. So you go to tool file, and I made it over here. So it says 180 because the diameter of this section right here is gonna be about 180,000. Okay. So I called it as 0.81, so 180,000 instead of E, as I usually do for an end mill. I call it as a T, so I know that it's gonna be a treadmill. So when you I covered this before, but every time you're gonna use a end mill, or pretty much end mill, face mill, chamfer, bone mill, you have to put those in a library or the machine's not gonna accept it. Okay, so 1.8 T, and C, so it's called 1.8 end mill. So you have an end mill, edge, nominal 180, T. These are your settings for your X and for your Z. The actual diameter set as a 180. I think it was like 180 or 182, like the actual. Okay, and then when you go to the program, let me move out of the way. I broke it down to 3 passes because, like I said, it was a pretty hard material. So you do it as a circle mill on X and Y. Position C is going to be a 0. It's going to set as a tornado. Now this is going to ask the diameter. So like how far you're going to go. Okay. So we're doing an M6 by 1. Got my calculator. So 6 divided by 4 equals to 236,000. I actually wrote it down. 236,000. This is the diameter you want to go to. Okay. So over here you don't state what kind of hole you have, and you actually do. So you do have a. So our hole was actually 200,000, and you're telling her. Let me see. You can see. So this is where I made a mistake over here, because usually these diameters and this diameter has to match. This is just kind of for your information. So you're describing pretty much they tool the depth, but what the machine's actually gonna do, it's gonna be on that middle lane. So you can change these stops as much as you want. So that was, it worked out, but it was my mistake. So let's go. So your position C, tornado 1, the depth, we called it out to go to 215, but on that middle lane, I called for 200, so this is where the machine actually went. So that needs to be corrected. 215. Okay. So now we have a depth, so we went 550,000. All the chamfers, everything's pretty much okay. Now this is where your pitch is. The first is going to be a 0. The second pitch, it's going to be 39,003 because it was a 1 millimeter pitch. Now we choose the tool, which is that 180T. The hole, this is how, so the hole original I drilled to 200,000. So now over here it's going to open. It's gonna do that spiral 215,000 deep. This is very important. So do it clockwise. If you do counterclockwise, you're gonna get a left-hand thread, roughing 7. You know your speeds 50, feed rate. Okay. And then all your, if everything is in the center, then all zeros across, as you see here. Now, so that's what was the second one, the first one. The second one is going to be exact copy, but we're going to 230,000, as you see. And the fourth one, we're going to 234,000. So we left pretty much 4,000 stock for last pass, and it was still deflecting a little bit, so I threw in a repeater. So pretty much a 4 pass that's also going to 234,000. It worked out pretty good. It was a lot of pieces, so that just a kind of free spin or free cycle pretty much kind of removed the material from the deflecting tool because it's a pretty small tool. So that's the whole trick to pretty much to the whole thing is so you just gotta remember, you know, once you have the tool, like I said, I mean the trick is pretty much, you know, just to kind of lighter machine they're using an end mill. So remember, it's kind of hard to like measure these. For the fact is that when you look at the tool kind of looks like this. They have these 3 points, so it's kind of hard to, you know, to measure here and here to be, you know, exact. So I was like 2,000 off, but like if you calculate from what I remember, it's kind of, you measure it and you give yourself a little bit room. So you know, always go a little bit smaller with these numbers. So for example, if you might be 5,000-10,000 off, you know, instead of let's say 234, I would do 220 on the last pass. You know, going with the gauge. If the gauge wouldn't go in, then open it up till you actually find find that spot. And what's very important is that bottom. The bottom has to be a 0, because if you put 1, 3, 4, 5, 6, 7, the machine's gonna drop and it's gonna try to clean up the face, and you might actually bottom out, or you might break the tool. So the bottom 0, and like I said, this is the whole program. Hopefully somebody found this useful, and thank you for watching. See you next time.